Hello everyone, today we'll be looking at usaco-training wormholes. In this problem, we're given n wormholes and we're supposed to assign them each a partner, or like each a pair, kind of. Okay, so we're supposed to make n divided by 2 pairs. And by pair, we mean that we basically connect 2 points, or connect 2 wormholes. So basically, when a wormhole is represented on a 2D map, which we're given the x and y coordinates, and then yeah, so we connect them when like something goes into the like one of the pairs, or let's just say it goes into A, and then it would just exit through B, and vice versa. So when it goes through B, it would exit through A. Okay, so an example is, let's just say we pair A and C. So when it goes into A, it'll go into C. Like it'll exit through. So then you just skip over here. It's kind of like a teleporter where you just like exit through your teleporter. Okay. And then when we pair it, we're supposed to find the number of pairings such that um the result can like is a cycle. And I mean by that is that, let's just say you have a wormhole connecting D and B and a wormhole connecting A and C. This can be a cycle because when you start from D and then you go, because you always move right. So when you go to C, you go into A, like you teleport to A, and then you move right, you go to B, and then you teleport back to D. So basically, this like creates like a cycle because it would be never ending. Yeah, okay, so this is one case, and the other pairing would be to pair, okay, it would to be pairing B and A and D and C. So thus the answer for this problem would be 2. So as you can see, we're given n and each of the x and y coordinate for the n wormholes. Okay. Okay, so let's just say we have a graph. So let's just graph this. So we're given n. So in this case, we're given A, B, C, and D. Okay. So as you can see, actually, you know that if you start from A, you're always going to go to B. Why? Because it's basically the next wormhole that's right of it. So you can see that if we actually label the next label of this, for example, next of A would be equal to B, and next of D will be equal to C. And to calculate this, you just loop through all the since n is only 12, you can basically loop through all the combinations, and you can basically loop through all the for a given wormhole, you can loop through the other wormholes, and you just check if the y coordinate is the same, and then you also check if there is already an answer. You just check if the distance is smaller, because let's just say we have a E over here. Like D wouldn't ever reach E because C would basically stop it. Okay. So why would we calculate next? Because since the coordinate range is in the range from 0 to 10 to the 9th power, you wouldn't want to just traverse all from, let's just say, 0 to 10 to the 9th just to find the next wormhole that you're going to go to. And so this basically just saves some time. Okay, so now that we calculated this, notice that the maximum n is only 12. So basically, we can try all the possible pairings. For example, we can also try, because in this case, we basically have 3 pairings, because because the three pairings are, let's say you can pair D with C and A and B. You could also pair D and B and then A and C, and you could also pair D and A and C and B. And you notice that there actually isn't a lot of combinations to pair. So first of all, we can loop through all pairings, and I'll explain that later. Okay, now second thing we need to do, we need to check if that pairing works. Because for example, if you pair okay, let's just say, okay, so if you pair D and A and then you also pair C and B, this wouldn't work because there wouldn't be a cycle. Since let's just say if you start off like over here at D, you just go to A, and then when you go to B, you would go to C, and then this would just go on forever. So that wouldn't work. Okay, so to check that, we can basically, because all our starting points are basically each of our wormholes. So first, to check, let's just go down here. I'm just going to write more. Okay, so now we need to check, okay? So number one, we need to set our start. It can be any of the wormholes. So let's just say from 1 to n. Okay. Now we can basically, since we have our next, right? And then so we can basically determine the next element of your start, because basically next of your start would be, for example, from A to B. Okay. And since you have this, let's just say you have D and B paired, and then you also have A and C paired. So for this, you know that the next right of A is B. So then, basically, your current one, you would just update it, because you have to keep track of what is your current one. So your current one would just update to D, because basically, so you know that this is your next one, but then since it teleports to its partner, so then basically it would become, let's just say, partner of next of start. And basically, let's just say for C and B, I didn't clarify this, so let's just give C, let's just give it 0, and then we'll also give next of B 0. So notice that if we iterate this like n times, which can fit, you can actually find out if it won't go into a cycle, or it would go into a cycle, because let's just say so this pairing would work because your first one would be A. Let's just say you start from A. You would go to B, and then from B you would teleport to D, so you would go to D. From D you would go to C, and then C would teleport back to A. And notice that if you do this like as many times, it would never reach 0, because let's just give 0 and like nothing. Okay, so basically let's just try and like a pairing that won't work. So let's just erase that. And let's also erase this. Okay, so let's just give this DNA, DNA and the CMB. Okay, so let's just say you start from D. Okay, so your next one would be, you would first go to C, and then you would go to B. Okay, you go to B. For B, since your next of B is 0, then since that, you would be like unable, so then this would just go to 0, which from 0 you just go to 0 and on. So then you know that this won't work, because at the end your current node would just be 0, which can't be true, since you want to be in a cycle, not like, you don't want to just like go away. Okay, so now to code this, so actually we should just check. Okay, so now to code this, we can calculate the start from 1 to n. Okay, and then you just loop through n times, and then you just update your current node. So you start from start, and then you just go to partner of your next of your of your current one. Okay. So now how do we loop through all pairs? Okay. So we can basically, let's just say we can have a list of things that aren't paired yet. So originally everything's paired, so let's just give them. Okay, so now we can first try pairing. We can first try assigning the first member of the pair as, let's just say, A. So now you have three choices. Okay. So now I have three choices, and then so basically you just loop through again which other pairs are not paired yet. So basically, since none of the pairs are paired yet, you can try pairing it with B. Okay. So after you do this, you would just mark this as used, and then you would like basically recurse it again. So then your next one that's not paired yet would be C. Okay, so now you have C. And then you're going to search for the next element or the next like other possible elements that haven't been paired, and it would be D. So then you would just pair these. Okay. And then after you do that, the next time you check, there will be no nodes or no wormholes that have not been paired yet. So then you check and then you just undo what you did before. Okay, so now you can also try pairing, let's just say A and C. So you would cross that, and then your next node would be B. So you would just pair that with D, and then again you would just check. So, and then next thing you would do is just pair A with D. That'll be gone, and then you just pair this, and then there you go. So now we know how to pair. Okay, so let's just get to coding since we know how to do it. Okay, so this is called Wormholes. Okay, so let's just include fstream. Okay. So we need our main function. Okay, so now we need our n, and then we're basically we also need our pairs, so we can have our x and y. So we have our x, and the max n is 12. So let's just give this 20, and also there we go. Okay, so we need to read from this is wormhole.n. So wormhole.n, and you're writing to wormhole.out. Okay, so you're reading n, and then for each of your n, you're reading the x coordinate and the y coordinate. So then reading x of I, and then you're also reading y of I. Okay. So now we need to calculate our next. So let's just call this next. So each has their 20. So originally our next should be equal to 0, meaning that it has nothing next. So next of I will be equal to 0. And your next of 0 would be also equal to 0 since you want it to keep on going. Okay. So now for each of your wormholes, you want to calculate the next one. Okay, so you should loop through all the other wormholes as well. Okay. So now you want to check, you don't want it to pair with itself, so you want I not equal to j. And then you also want the y coordinate to be the same, so y of I equals y of j. Okay. And then basically so let's just say if I originally did not have a pair or have a next. So then it would be not next of I. Or so if it did have a pair, you want the oh yeah, and one more thing. So you also want the next one of the x coordinate has to be greater or equal to your current one. So and x of j has to be greater because you're always moving right. So then if the x coordinate was before your the current one you're calculating, which is x of I, then it would never reach it as well. X of I. So so now if it hasn't been assigned, so now you want to calculate the one of the minimum x, so or x of j is less than x of next of I. So if you do that, then you just set next of I would be equal to j. Okay, so now let's just make a pair. So it would be so let's just call this our DFS function. Okay, so what we actually need like an array to represent if we have paired the wormhole or not. So originally it would not be paired. So pair of I would be equal to 0. Okay, so now we need to basically DFS. Okay. So now we need to calculate the first element that's going to be paired. So we can have, let's call this F. Originally it would be -1 or nothing. So now you have to go while, and then you also have to have index. So and then you also have let's just say we can actually have f of equal to 1. So while paired of f, so while it is paired, so because you want the first element, so you want to loop through all the elements that have not have been paired, because you want to skip them. So then while paired f, and you want your pair to be less than or equal to n. Okay, so that's the case. Then you want to increment your f. Okay, so now if you haven't found it, it would be f of would be equal to n plus 1, because it would be equal to n, and then it would still be paired. And so now basically, so for this case, then f would just go out of bounds, so it would be here. Okay, so now we need to basically, let's just do check. So we didn't write this yet, we'll just come back to this later. Okay, so now we need our second element. So we can loop through from f plus 1, and then it would be less than or equal to n, and then every time you just increment your s. Okay, so every time you want to check if it's not paired. So if not paired, s. So if it's not paired, then you can pair these two nodes. So then you can mark paired of f be equal to paired of s, so be equal to true since you're pairing it. Okay, so now basically you want to DFS again because you want to DFS further. Now after this, you would just set this to false since you're trying to pair other nodes. Okay, so now basically all we need to do is just write our check function. Okay, so let's actually, so if check, so we need to make our check function. So this should return a Boolean value. So if check, okay, and we actually should have our partner, like we should keep track of which partners. So over here we should do partner of f would be equal to s, and partner of s would be equal to f. And here just set these two to 0. Okay, so now we need to check if this combination works. So okay, so our starting points can be either from any node, so we can check that as well. So we need for, let's start equals 1. Start has to be less than or equal to n, and then every time you want to increment it. Okay, so now we should have our current, which originally would be equal to start. Okay, so we should iterate this through n times, so we can do it. Let's just call this it. And every time, as I said in my my drawings, your current would be equal to the partner of your next of your current one. Okay, so now basically, if it's equal to 0, then it means that it's not in cycle. So if not cur, then you can return. Or actually, if you found a cycle, then you can return true. So if cur, then you return true. And so if it didn't work for any cases from any starting point, then you just return false. Okay, so now basically if our check works, then we have to increment our answer, so answer. Okay, so now we need our variable for our answer. Okay, so now we need to call our DFS function. So we already did, and originally we should set our answer to 0. So all now we need to do is just to print the answer. Okay, so let's just run it. This is wormhole.in. Okay, so this is our. Okay, so I'm running it. Okay, yeah, I forgot to use using namespace std because it's a standard form. Okay, so 2, which is right, and I'm just going to try to submit it. So this is, my ID is download3, this problem is wormhole, and the language is C++11. Okay, let's go to here, and I'm just going to select my files. Usaco-training, this is Wormholes. Okay, so main.cpp, so let's submit it. Okay, so it looks like that is right. Okay, so if you have any questions, feel free to leave them in the comment section below. Bye.